It is at this point I wish to try and communicate a point of view that has played a very critical and fundamental role in my reasoning, and hence mathematical exploration. A black hole is most typically described as being a point of infinite density whose gravitational pull is so strong that not even light itself can escape it. But what is it that we can actually say about it from inference? From the point of view of Bohr's model of the atom, the vast majority of the volume inside an atom is empty space. Only around 1/1000th of the volume of an atom is actually occupied by the particles that make it up. The rest is empty space. For example, if a hydrogen atom were the size of the Earth, then the proton at the center would only have a diameter of about 200 meters. As another analogy, imagine if you took all the atoms that make up the entire human race, you, me, and everyone else on the planet. If all the empty space was removed from the atoms that make up every human being, then the remaining volume would fit inside a single cube of sugar. The electrons of a white dwarf are all packed very tightly together. There is not much space between the densely packed electrons, but the volume of this empty space is far greater than the packed density of a neutron star. Here, the electrons are fused with the protons in the nuclei to become neutrons. The only space now is between the densely packed neutrons. The next logical step is that the neutrons in turn are fused together into a single solid mass. That is, all the fundamental particles are fused together into a single volume. Namely, it is incompressible and no longer composed of other particles, as they are now all fused together into one single mass. An elementary or fundamental particle, by definition, is a subatomic particle with no substructure, thus not composed of other particles. So would it not be correct to actually call a black hole a fundamental particle? It is after all said to be infinitely dense, rather like Dirac's delta at zero, where all the particles have been fused together into one single indivisible volume. Hence, black holes are in actual fact, by definition, a fundamental particle of nature. The very idea or notion that a black hole is actually a fundamental particle of nature in and of itself could best be described as a nightmare of cognitive dissociation. I truly have known madness. Heretical blasphemer is the phrase that screams in my mind, but science is not religion. I myself would have outright rejected my own idea if it were not for the Einstein-Rosenbridge equals Einstein particle-Rosenbridge conjecture by Leonard Susskind and Juan Maldacena. The cognitive nightmare of madness, in which the statement, a black hole is a fundamental particle, played a pivotal role that drove me to try and nullify this whole idea of mine. Instead of nullifying, rather, I have amassed a massive portfolio of evidence from observations to lab results. In fact, I have tried in vain to test the logical predictions about my idea, only to find that my very rough predictions or hunch may be very real. These days, I find that I am now very carefully listening to credible UFO witnesses, all the while screaming, "I knew it. That's how flying saucers work." My jaw is on the floor at the sheer beauty and simplicity of these craft. We who think we have mastered the wheel, we have not. We are only just beginning. But it is in this single idea, or rather change in perspective, with respect towards the problems of quantum mechanics and cosmology, that was for me the great enabler. What is the difference between a black hole and an elementary particle? None. They are both incompressible and indivisible volumes of matter.